Okay, so let's look at getting into more actual examples of how this works. So at the heart of the program is this variable notes. And as you can see, it's a list of values with an offset. You don't need to use the offset. You could literally say this is 60. You could say this is 63 and eliminate that offset. I find it's a little bit helpful to use the offset because you can more easily see relationships between the notes. For instance, if this is, it doesn't have to be your tonic, but if this is kind of your root, then this is, a minor third in relation to that. This is a perfect fourth in relation to that. So it's really easy to see when you reduce them to smaller values in relation to 0. So as a sequence of notes, you'll be dealing with either like a list or a nested list. The nested list is kind of more if you're dealing with chords, and we'll get into that in another section. You can play these values in any order. There's kind of no default. I'll get into that in a second, but it's just important to think that this is like your raw notes, and then what you do with those notes is kind of up to you. This next couple of variables, I'll just mention what they are because they're next and you might be curious about them, but those I'll address in a different section. This scale is for setting a pitch scale, which you can then use to auto-generate chords and things like that. We're not going to use it right now. This mode select it auto-generates a mode from this scale. Again, this is an index for SuperCollider index convention. So in other words, this is index 0, this is index 1, 2, 3, and so forth. So this is the basic mode. In other words, mode select is just this is the mode. If you would put in a 1 here, it would generate a mode from the second node of the scale, and so forth. Again, we're not going to use that just now, but I just wanted to mention what that is. So what you actually do with that. Now, this next section is a little bit confusing, and hopefully it makes sense. Basically, this variable is chords becomes a little important, and this is a 0 is off, 1 is on kind of situation. If your notes value is a simple list, you want this to be a 0. If it's not a 0, it's going to cause an error when you run it. I did look at creating a kind of an auto select function at one point, and it caused some other problems. So again, that's a case of if a better programmer were working on this, they would probably find an easy solution to that. But I just kind of left it, and it was easier for me to just select it on my own. If it's a nested list, in other words, if you're dealing with chords, you want to select this, you want to change this to 1. So if I were using, for instance, this version of notes instead of this version, I would have to change this to a 1. But we're going to leave that as a 0. This is ARP. I'll explain that in a little while. You don't need to be too worried about it because this is an example of where there is a quick auto select. If this were a 1, you could have this either be a 0 or a 1, but if it's a 0, as you can see, the program is saying this can't be a 1 if this is a 0. Yeah, I wouldn't worry too much about isArp at this moment. But basically that determines if you are using chords, in other words, a nested list, 1 will arpeggiate those chords, and 0 means that it's just going to play the chords themselves, like groups of notes. So I'm going to skip this little section here, and I'm going to go down to this section, ARP rhythm and order. So for the purposes of my own nomenclature, I kind of called a melody an ARP, just for arpeggio, since you're really, in a sense, you could think of this note definition as a chord that we're going to be arpeggiating, right? So if you want to think of a melody could be thought of as a larger chord that you've just selected notes from. And that's kind of how this program approaches melody. So under this ARP rhythm and order, basically this is where you determine the rhythm at which those notes play back and the order at which they play back. The ARP rhythm is, as I alluded to before, in beat numbers. So this is 3 quarter notes, 1 quarter note, 2 quarter notes, 2 quarter notes, 1 quarter note, 3 quarter notes. This ARP scale I'll talk about at some other point. Don't worry about this ARP ratio rhythm yet. Rest again I'll go over. ARP order is the next one that we really want to look at. And this is another one of those index selectors. So this is basically selecting which index of that notes variable we're playing. And it's so a 0 would be the first index, a 1 would be the second index, and so forth. It's important to know that it wraps. So if, for instance, as you can see, our original notes variable only has 3 indexes, but here I have, so really it would only, you would think it would only accept values of 0 to 2, so 0 for the first index, 1 for the second, and 2 for the third. But as you can see, I have larger values here. It would wrap. So 3 would be, if there's only 3 indexes, 3 would be the 0, 4 would be 1, 5 would be 2, 6 would be 0 again. So it wraps, if that makes sense. Now, there's this variable here which auto-generates ARP order. What this does is it disregards this variable here. So as you can see, I have it, this is an on or off sort of situation. So 0 would be off. If you had 0, ARP order is now kind of being heated. If you have it on, as I do now, it's auto-generating the order, meaning it's going to step through this notes value in order in that direction. And it's going to loop. So where did I go? So if you just want the most simple setting, basic setting, if you want to program that melody in order or play that melody in order, you just keep this as a 1. If you want to get more creative, you can set this to a 0 and then play with this variable here. So let's look at a quick example, because I've talked a lot without actually playing anything. So let's just run the program as it is, and we'll see what happens. I'm going to keep this really simple at first, just so you can hear what's going on. You can kind of see in the debug information here, it's spitting out information about what note it's playing and other information. Again, not really important. You might not see that when in the final version here. As you can see, it's playing note 60, it's playing note 63 and 65 over and over again. And it's playing it at the rhythm we defined down here. So 3 quarter notes, 1 quarter note, 2 quarter notes, 2 quarter notes, 1 quarter note, and 3 quarter notes. Now, the period of interference here is not that hard to understand. It's not very interesting because there are 3 notes and 6 rhythmic values. So it's going to be 60 at 3, 63 at 1, 65 at 2, and so you can see it comes into phase very easily because there's 2 sets of 3 notes in each of these. Now, if we stop it and we wanted to create a period of more interesting interference, we could eliminate one of these. So now we'd have 60 at 3, 63 at 1, 65 at 2, 60 at 2, 63 at 1. Now it's going to do 65 at 3, 60 at 1, So as you can see, the pattern is going to, again, it's still going to be pretty boring, but just in terms of the pattern of interference, you can already hear how there's a bit more variety there. Again, this is about as simple as it gets, so this is not designed to be exciting at this point, but I'm just keeping it simple so you can clearly hear what's going on. The next thing that I'll mention right now is this rests function. And this is a bit, hopefully I can make this easy to understand. This is one example of where the sort of numbering convention changes a little bit. This is a different type of data. Here the rests step through in sequence, meaning there's no, the rhythm is what you define here. So for instance, this is the one that's active. There's these other commented out versions. Let's just make a list. So as you can see, as it exists, there were 0 rests anywhere. The notes were just playing in sequence. If I wanted to, if I do this, this means the first note that it encounters is going to not be a rest. The second note is going to be a rest. When it does this, it ignores the pitch. So in other words, it's not kind of eliminating anything. It's just not going to play for the duration of whatever rhythm it encountered. So for instance, it's going to play note 63 for 3 beats. Then it's going to rest for a beat. And this loops. In other words, so it's going to go 0, 1, 0, 1. So not rest, rest, not rest, rest, not rest, rest. So again, so it's going to do 60 at 3 beats. It's going to rest for a beat. Then it's going to do 63, note 63 for 2 beats. Then it's going to rest for 2 beats. And then note 65 for 1 beat. Then it's going to rest for 3 beats because we're here now. So let's hear what that sounds like. Again, not super exciting, but you know, you can use this to create quite a bit of variety. So I'm just going to undo that here. I'm going to comment this out, and I'm going to use, let's use this one, it's pre-programmed rest pattern. So it's going to rest for the first note, then play the next 2 notes, rest for the next one, play the next 4 notes, rest for the next one, play the next note, then it's going to rest, and it's going to just keep repeating. So it basically loops, and whichever note it encounters, it's going to rest for whatever value is encountered next in this. So again, here we've got a pattern of interference. Actually, let me use the other ones just to make it a little bit more simple. So let's use this one. So we've got a note pattern of 3 notes. We've got a rhythm of 5 rhythmic durations, and we've got a rest pattern of 4 units. So as you can see, the pattern of interference is already going to get more complex. So again, not super exciting yet, but I'm keeping it simple just so you can hear what's going on. And that's only 3 different variables and very, very not interesting information put into notes. And already we can see that if we played that, it would take a while before that came back into phase and actually repeated due to the interference between those different elements.